Assalamu alaikum guys, welcome back to Civil Engineers YouTube channel. Today in this short video lecture, I will guide you specially for lapping length in beam, column, slab, etc. Especially in steel structure design. That what should be the lapping length formula for beam, column and slab from the reference of IS 456-2000. Let's get started. If this video is helpful for you, so you may like this video. The topic is lapping for beam, column and slab. So the first one is lapping for column. So what is the formula to take lapping length for column? As I told you, the reference is IS Indian Standard Codes 456-2000. Okay, you can find the reference in this reference. Okay, these things. So for compression, because the column is compression member, so therefore you can see guys, this is a column. Okay, here we will provide the lapping like this. Okay, so this is lapping length. So how we can get this length? This one. Okay, so the formula is for lapping length, which is 45D. Remember guys, where D is die of steel rod. For example, if the die of steel rod is 12 mm, so now the formula will be, so 45 multiply 12, then you will get the value of lapping length in mm. Okay, anything, so that should be lapping length. But for beam, column and slab, the lapping length should not be less than in IS 456-2000. Okay, so lapping length should not be less than 75 millimeter. Okay, it should not be less than 75 millimeter. But if you want to provide the lapping length, so the length should be with 45D for column. Now guys, where is the place to provide lapping length? This is very important because many people, they don't know. So if you need to provide lapping length, so in any place they are able to provide, but this is wrong. So what is the proper method to provide lapping length? Remember guys, here the lapping length should be provided. For example, this is the height of column. This is height. For example, height of the column is 12 feet. For example, so the height should be divided by 4. Okay, for example, if I divide height by 4, for example, 12 divided by 4, so it becomes 3 feet. Okay, so after 3 feet, okay, after 3 feet you are able to provide lapping length. But the lapping length should also not be provided at the bottom and also at the top. But also mid is not the place to provide lapping length. So after 3 feet, as I told you before, h divided by 4, height divided by 4, then you will get the length 3 feet. So after 3 feet, you are able to provide the lapping length with the formula of 45D. So this is the place to provide lapping length. Now guys, the lapping length, for example, if we provide one lapping length for longitudinal bar at this position, so the other will be not, so it should be alternately, not at the same point. So if you provide lapping length at the same point, so that is the place to make collapse. So it will make the column collapse. Okay, so therefore this is very important, especially for lapping length. Okay, So it should be provided alternately. The other question is, guys, for lapping length. Okay, so if you provide the lapping length at the end, okay, for example, here we have a slab. Okay, also at the bottom we have the other floor. Okay, so don't provide at the bottom and also at the top. Okay, because bending moment are maximum at the top and also at the bottom. So therefore L/4 is the best place to provide a lapping length. Now come to beam. Okay, so this is the first one. The second one is beam. So lapping length for beam. Okay, lapping for beam. Remember, guys, in beam we have two portions. Let me show you it in long section. So the top portion for lapping, so this is compression zone. And the bottom is tensile zone or tension zone. Okay, so what should be the lapping length formula for compression zone and for tensile? Because we are not able to use one formula for lapping length, especially for these two. Because as you know, concrete is weak in tension, but it's strong in compression. So in the compression zone, the lapping length should be less than tensile portion. Okay, so therefore, lapping length for compression zone, the lapping length should be 24D. Okay, so here for the tensile, zone or tension zone, you can say. Okay, so here we should provide the lapping with the formula of 50D. As I told you before, D means die of steel rod. For example, if the diameter of the steel rod is 16 mm or 20 mm or 24 mm, anything. Okay, so the D should be die of steel rod in millimeter. Okay, so now guys, remember, now where is the best place in long section of the beam? For example, for compression. So for the compression zone, the lapping should be provided at the mid. Okay, but here in tension zone, it should not be provided at the mid. Okay, as I told you before, that concrete is weak, not strong in tension zone. Okay, so therefore this is the place which I am showing you in the figure. Guys, you can see these are supports. Okay, for example, this is continuous beam. Okay, so these are supports. So here try to provide lapping length and tension zone at the joint. Okay, so this is the joint, so provide here like this at the bottom. Okay, but at the top portion, for example, we have, this is the section for the beam, right? 2 at the top and 4 steel rods at the bottom. As I told you before, that concrete is weak in tension, so therefore in tension we will use more amount of steel, or we can use maximum steel rods compared to its top portion in compression zone. So therefore the lapping length should be provided at the junction between beam and column. As you can see, this is beam and these two are columns. So therefore it should be provided at the junctions, also at this place. Okay, you can provide the lapping length, but at the top, okay, provide the lapping length at the mid. At this position you can provide a lapping length. So the formula for the compression zone should be 24D, and for the compression it should be 50D. But never forget it one thing, guys. As you can see, this is the length of beam, this is the span. For example, the span is 16 meter. For example, the span is 6 meter. Okay, so if the span is 6 meter, so don't provide the lapping length with the distance of L/4. So let me discuss in detail. So when you do it by L by 4, so 16 by 4, sorry 6 by 4. So here we have 1.5 meter. So here from this place, from the start to end, so this is span, clear span, length of the beam. So therefore to the distance of L by 4, which is here from the calculation 1.5 meter from this side and 1.5 meter from this side. So don't provide the lapping length at these positions, okay, L by 4 distance, because we have maximum shear stresses at the end of the supports. If you provide cracks, actually shear stresses can provide maximum cracks at the end of the support. So therefore we provide crank off bar or bent up bar, because at this position L by 4 distance we have maximum shear stresses, so there we have negative bending moment, as I told you in many videos before. So therefore at the mid we have positive bending moment. So let me draw a section. For example, you can see this is a beam, this is beam, and these two are columns, okay. So when the load comes on the top of the beam, so the beam will make a shape same like this. Look here. So here we have positive bending moment and here we have negative bending moment. To resist shear stresses, we will provide stirrups closely compared to its mid spacing. Stirrup spacing should be maximum compared to L by 4 distance, because we have negative bending moment. So therefore to resist negative bending moment, the stirrups should be provided closely. At the mid we have bending, actually we don't have shear stresses, zero shear stresses or minimum shear stresses, so therefore we don't need to provide closely the spacing of stirrups, okay. So this is very important for you to know about this. So to resist negative bending moment, okay, our shear stresses are maximum, so here we provide bent up bar. So what is bent up bar? Guys, you can see the steel are bent at this place, also here like this. Guys, you can see clearly. To resist negative bending moment, we should provide bent up bar or crank bar, okay, with the distance of L by 4 as I told you here. So this is very important. So now what is the formula? 24D for compression, for tensile zone 50D. Where is the place? At the top. Try to provide lapping length at the mid, but try to provide lapping length at the junctions. Don't provide with L by 4 distance, otherwise you will face more problems in steel structure design, and the beam column or this structure will provide a lot of cracks. So therefore remember these things which I have discussed. So now lapping for slab, okay. So lapping for slab is, the last one is, sorry for this, lapping for slab. So the formula is 60D, again where D is die of steel rod, okay. So in slab, where is the place to provide lapping length, okay. So the lapping length should be provided in the slab where we have negative, if we don't have bending moment and minimum shear stresses, so that is called point of contraflexure. So that is the place where I have discussed in many videos what is point of contraflexure, and you can search also in the Google to know where is the place for point of contraflexure, okay. Then you are able to know where is the place. So this is very important for you. So we are not able to provide at the mid, also at the end of the support. So for that we will solve the equation, especially for the slab. Then you will find out the point in which you can keep the lapping length for the slab. So guys, this is the topic especially for lapping length, beam, column and slab. So if you remember these things, so you will not make any problem on construction sites, especially in steel structure design. Hope this video can help you. Thanks for watching. See you in next video. Goodbye.